Hello everybody and welcome back to RE7, your channel for mastering science and physics in a clear, simple and enjoyable way. Today, we're diving into an important principle of fluid mechanics, Pascal's law, a concept first identified by the French mathematician and physicist Blaise Pascal. This principle forms the foundation of modern hydraulic systems used in machines all around us, from car brakes to lifts, presses, and even heavy construction equipment. In this lesson, we'll not only understand Pascal's law itself, but we will also walk step by step through a real example problems involving hydraulic pistons. And to make learning even more interactive, I will also show you Python code that solves these same physics problems. This will help you understand how physics formulas can be turned into a working computer program, something extremely useful for students who want to connect science, math, and coding. To begin, here is a simple Python function that we will use later to calculate forces based on Pascal's law. Pascal's law states, when pressure is applied to a confined fluid, the pressure is transmitted equally in all directions throughout the fluid. This explains why a small push on one piston can lift a car on the other side of a hydraulic lift. Pressure moves uniformly through the oil or fluid inside the system. In mathematical form, where F1 input force, a 1 input piston area. F2 output force, a 2 output piston area. Hydraulic systems amplify force. A large piston always outputs a larger force than the input piston as long as the area is larger. Let's look at these calculation questions together. 1. Hydraulic press problem. A hydraulic press has an input piston with an area of 5 square centimeters and an output piston with an area of 50 square centimeters. If a force of 20 N is applied to the input piston, what force will be produced at the output piston? Now, let's calculate the output force manually. Using the ratio F2 equals 4 times 50 equals 200 Newton. To demonstrate how Pascal's law can be applied through programming, the following section prepares a well-structured prompt that can be used to generate accurate Python code for calculating the output force in a hydraulic press problem. By providing a precise prompt, we ensure that the AI produces correct and reliable code for automated calculations. As you can see, the calculation produces the same result, 200 newtons. Now, let's break down the Python code together to ensure we fully understand how each part works. This will help us see how automated calculations can be used to solve physics problems more quickly and accurately. 1. Setting the known values, variables. In any physics problem, the first step is to list what you know. In Python, we do this by creating variables. F1. This represents the force you are applying, like pushing down with your hand. A 1. This is the size, area, of the small piston you are pushing on. A 2. This is the size of the large piston that will lift the heavy object. 2. Applying the physics formula. This is the brain of the script. We are telling the computer to follow Pascal's law. F1 divided by A1. This part calculates the pressure. Since pressure, P is force divided by area, the computer finds that the pressure is 4 newtons per centimeter. 2. Time by A2. Pascal's law says this same pressure travels to the other side. By multiplying that pressure by the larger area 50, we find the new, much larger force. 3. Displaying the result, the output. Calculations happen inside the computer's memory, so we use the print function to show the answer to the user. The F before the quotes allows us to put our variables F2 directly inside the text. When the code runs, it replaces F2 with the calculated answer, 200. Now, let's choose a new set of input parameters for our Python program. We will enter different values for the input force F1, the input area A1, and the output area A2. After providing these values manually, Python will automatically perform the calculation for us. Before doing that, however, we must prepare a clear and accurate prompt to ensure that the AI generates the Python code correctly and produces the results we expect. If you're unsure whether the script in your prompt is fully correct, you can ask the AI to review it and verify all the details. This helps ensure that the prompt is accurate before generating the Python code. Now, I will paste this prompt into the AI and let it produce the Python script for us. Let's see what result we get. Now that we have received the complete Python code from the AI, we can copy and paste it into our environment for testing. Next, we will enter our chosen input parameters. These values, listed in the table, will allow us to test how the program responds to different conditions. Now let's enter the different values to test our Python program. You will see that the code automatically performs the calculation and produces the correct output each time. The physics, Pascal's law. At the heart of every hydraulic system is Pascal's law. It tells us that pressure applied to a confined fluid is transmitted equally in all directions. The formula, the magic. By pushing on a small area a 1, we create pressure that can lift a massive load, like a luxury car on a larger area a 2. The engineering advantage. We call this mechanical advantage. In our examples, if the output piston is 10x larger than the input, your lifting force is multiplied by 10. This is the exact principle used in car jacks, heavy machinery, and the irrigation systems you work with as an engineer. 3. The Python solution. Instead of doing manual calculations every time, we used Python to automate the process. Our script captured inputs, handled forces and areas as floating point numbers, applied logic, calculated the system pressure first as the bridge between both pistons, provided feedback. Not only gave the answer, but confirmed how many times the force was multiplied. Final takeaway. Engineering is about understanding the laws of nature. Python is about making those laws work for you efficiently. If you found this lesson helpful, please don't forget to like the video, leave a comment, and subscribe to the RE7 channel. Your support helps us continue creating clear, high-quality lessons to guide you through physics and other science topics. Thank you for watching, and I'll see you in the next lesson.